So this is problem 9 in Mastering Physics. It's asking us about a charge, the charge on a thundercloud. So it gives us a bunch of information. Our cloud is going to be modeled as a sphere of diameter 1 kilometer, and it's wanting us to solve for the max amount of charge the cloud can contain without breaking down. So there's some point at which the magnitude of the electric field at the surface of the cloud reaches a value that breaks down the surrounding air. That breakdown ionizes the air, which causes thunder and lightning to occur as it's conducted downwards. So our breaking point value is 3 times 10 to the 6. And you can see with my picture on the right, we're going to be using Gauss's law to solve this. So luckily, since we know that if the electric field everywhere is perpendicular to a surface and has the same magnitude E at every point, the electric flux through the surface is just E times A. So that's kind of what I wanted to show with this picture, is that because of the spherical, symmetrical nature of this shape, we can use that aspect of Gauss's law to make this a very simple problem. Also notably, when you're using Gauss's law, you obviously want to use the closest shape, the shape that makes the most sense. So here our shape is just going to be another sphere encasing our charge. So moving on, as I was saying before, can use that information about the electric flux and electric field and everything to make our top equation, which is that very essential electric flux equation, into a much simpler one, which shows EB, which is our breaking point of our electric field, times the area of the cloud, equals Q over epsilon naught. And you can see at that point we have all the information we need to solve. The only thing is, because we're using a sphere, we are wanting to just use we're going to use the surface area of a sphere for our area of our cloud, which is just 4 pi r squared. But once we do that, we can solve. So just rearranging terms and plugging things in, always keeping in mind with the radius that you need to correctly convert things. So originally, for example, we were given the diameter, so it can be kind of tricky sometimes to remember to divide that by 2 and then also convert it to meters, because if you don't do that, you're going to get a very, very different number. But having done that, we get a total charge in our cloud of 83.4 coulombs, which, if you think about, if you were to convert that to electrons, how many electrons are in that cloud, it is a massive, massive number. So it is an interesting way to think about why electricity, for example, is such a large reaction, something that's so kind of violent, I guess. It's interesting, but that's pretty much it. Overall, the problem's not too bad as long as you can set it up and make it really simple. But yeah, that's pretty much it. Thank you for listening.